It always does that in the second recording for some reason. All right. So to find our f of 27, it's pretty straightforward. Let's go and do the cube root of 27, which equals 3, since 3 times 3 times 3 is 27. Okay. Now to find our f prime of 27, we have to find our f prime of x first. Okay, so we know that, I'll put it in here, f of 27 is equal to 3. And the only reason I created that little box is because I hate trying to look across the whole page and see what an answer is, so I like to have them right there in one spot. That's not completely necessary if you don't want to do that. Okay, so f prime of x, well, first we'll make f of x equal x to the 1/3 power. Make sure that's thoroughly erased. There we go. So that means our f prime of x is equal to, we're going to bring down our 1/3 and subtract 1. So if you subtract 1, let's say 3 over 3, that'll make that 1/3 x to the negative 2/3 power. Which, if you wanted to simplify it a little bit more, f prime of x is equal to 1 over 3. Bring that negative exponent down, so you can make that x squared to the 1/3 power, since that's to the 2/3 power. Which means your f prime of x is equal to 1 over 3 cube root of x squared. Okay, so now we just have to find f prime of 27. That's equal to 1 over 3 times the cube root of 27 squared. And this is where you can kind of manipulate the radical a little bit. Remember, the cube root of 27 is equal to 3. So you can just make that the cube root of 27. So that's 1. Kind of separate that a little bit. Over the cube root of 27, which is just 3, times the cube root of 27 squared. Okay. Now remember, if you have the same index on both radicals and they're multiplying them, you can combine them. So this can just equal 1 over the cube root of 27 times 27 squared. So all we did was just combine those two, which is the cube root of 27 cubed. The index and the exponent cancels each other out. Straighten that up a little bit. So our f prime of 27 is actually equal to 1 over 27. Okay, so right up here, f prime of 27 equals 1 over 27. Alright, so let me go ahead and separate that just a little bit. Okay, so if we plug it into the formula we started with, our linear approximation is equal to f of 27, which is 3, plus f prime of 27, which is 1 over 27, times x minus 27. Okay. So this is your linear approximation at x equals 27. Okay. So we want to know the estimate at x equals 26.9. So the linear approximation of 26.9 is going to equal 3 plus 1 over 27 times 26.9 minus 27.
Maybe a little behind on that one. When
Hmm?
you're saying when you process the f prime, how you add another, you go and you multiply another 27.
Yep. So really what we did was we used the rule, and I believe it's in Math 1000, where if you have the
Rationalizing the denominator.
nth root of a times b equals the nth root of a times the nth root of b. And it also works the other way. So since we had a cube root of 27 and a cube root of 27 squared, we just brought them all under the same radical, which gave us 27 cubed. So if you have the cube root of 27 cubed, they can. Exactly. Yeah. I know it's a little bit tricky.
Couldn't spot it from me.
Could we have just plugged in 27 to the first one that you got? 1/3 x to the negative 2/3?
Which part are you?
All the way up at the top. You go right there.
This one?
Yeah.
Oh yeah, you could have plugged it in there.
Okay.
I don't know if it would have been much help, but you could have plugged it in there. All right, so this actually gives us 3 plus 1 over 27 times 0.1, which if you plug that into your calculator, gives you 2.9963. Bring that down here. All right, any questions on that one? All right, I'll leave that up for a few more seconds. Excuse me. All right. One more. Let's say we wanted to use a linear approximation of f of x equals sine of x at x equals pi. To approximate, let me clean that e up a little bit. Sine of 183 degrees. And we're going to give the exact answer and 4 decimal places. Okay, so even though we're dealing with trig functions, it's the exact same process. Nothing changed. Our linear approximation is equal to f of c plus f prime of c times x minus c, where in this case c is equal to pi. So linear approximation is equal to f of pi plus f prime of pi times x minus pi. So that means we need to find our f of pi and f prime of pi. Okay, so we know our f of pi. Since f of x is sine of x, f of pi is sine of pi, which equals 0. Okay, and our f prime of x, derivative of sine is cosine, so that's cosine of x, which means that our f prime of pi is equal to cosine of pi. And cosine of pi is equal to -1. Okay, so that means we know that f of pi is equal to 0, and f prime of pi is equal to -1. Okay. So now we just go ahead and plug it in. So our L of x is equal to f of pi, which is 0, plus f prime of pi, I guess you can call that -1, times x minus pi. Or you can just drop the 0 and make it negative x minus pi. Uh-oh. Okay, so this is your linear approximation at pi. Okay. Now, if you remember, because it's a little bit off, because if you notice here, pi is a measure of radians. And here you have a measure of degrees. So we have to convert our degrees to radians. So that 183 degrees, to convert degrees to radians, you have to multiply it by pi over 180. So that's going to equal 183. Let me write that out a little bit. 183 times pi over 180. And you can put a little radians there if you want to, but you don't have to. So that's going to equal 183 pi over 180, which simplifies to 63 over 60. I mean 61 over 60, sorry about that. 61 pi over 60. So 183 degrees, we can actually rewrite it as that. Okay, so our linear approximation of 183 degrees is actually our linear approximation at 61 pi over 60 radians. Okay, which is equal to, clean that up a little bit, -1 times 61 pi over 60 minus pi. Okay. So if we're going to subtract, we're going to need our common denominator. So we can make that -1 times 61 pi over 60 minus 60 pi over 60. Okay, which gives us -1. 61 pi minus 60 pi is just pi. pi over 60, which is negative pi over 60. Okay, so this would be our exact answer. If you plug it into your calculator, you'll get some negative 0.0524. That's the 4 decimal places. Oh, move that up a little bit. All right, so any questions on that one? All right, leave that up there. Okay. Okay, so now we're going to cover Rolle's theorem. So what if we have a function f of x that's continuous on a closed interval we'll say from a to b, and differentiable on the open interval from a to b. Okay. So if those two things are met, we can pretty much say that if f of a equals f of b, then there is at least one value of c in that interval of a and b where f prime of c equals 0. Oh, clean that up a little bit. Okay, so if we were to look at that as a graph, oh, thought your hand was up. Let's say we have our x and y axis here. Say if we have some graph, we'll just draw that, any random graph. Okay, let's say this is our A. This is our B, which means that our f of A and f of B are equal. That means at some point, since it's continuous and differentiable everywhere, at some point there's some c value that would give you a slope of 0. Okay, so let's say that's the c value there. So somewhere in between there, you're going to have a c value where you have a slope of 0. All right, any questions on that one? All right. So let's say, for example, we want to find the, well, value of C value. So you find the value of C in the interval -9, -1, guaranteed by Rolle's theorem for g of x is equal to -2x squared minus 20x minus 15. And note that we know that if we plug in both of those endpoints, g of -9 is actually equal to g of -1, which they both equal 3. Okay. Sometimes they'll give it to you, sometimes they won't, but if you just plugged in your endpoints, you could find that out. Excuse me. Okay. So we know that the g of x is continuous over every point because there are no values of x that if you plug it in, you have anything undefined or negative square roots or anything like that. So we know it's continuous. And we know it's differentiable at every point. Well, it's continuous on the closed interval and differentiable on the open interval. Oh. So that means we can actually use Rolle's theorem on this one. Okay. So we know that since g of A and g of B are equal, then there exists an f prime of C is equal to 0. So all we have to do is find our f prime of C. So not f of C, G. So used to writing f. So G of C is just -2c squared minus 20c minus 15. Our G prime of C is equal to 4c, -4c, minus 20. So we just have to find out where G prime of C is equal to 0. So that means we just have to find where -4c minus 20 is equal to 0. But if we add 20 to both sides, divide by -4, we know that C is equal to -5. Okay. So if we plugged in that -5 into our original equation, we would actually end up with the point where the slope is equal to 0. So 5, G of 5 is the point on the graph where the slope is 0. You don't have to plug in the G of 5, but if you were looking for it.
Would you be plugging in G of -5?
Oh, -5, thank you. Yep, -5, G of -5. Any questions on this one? All right, leave that up for a few seconds.
So then at the point, -5, 35, that would be the peak of the curve before it goes the opposite direction?
Yep, if g of -5 is 35, then that would be
Okay.
the point there. All right. And it's going to shut off in like 4 minutes, so I might as well